It's gonna be one man in shorts. Okay. Always.
All right, so, for this one right here, okay, so I'm going to go back to what I said last week. Now, for this problem, to get full credit, you have to show all the work. We're talking about all the algebra. If you only do the calculator part, then it's only partial points. But for this one right here, it is going to be algebra. Got to do the algebra. So the first thing I'm going to do for this is set it equal to 0. So I'm going to set the whole thing equal to 0. So 3 cotangent squared theta minus 3 cotangent theta minus 1 equals 0. Now, this is a trinomial, and my variable here is cotangent theta. So if it's a trinomial, that means that I'm going to have to factor this, because right here, I don't have anything that normally comes up with 3 times negative 1 is negative 3, so I'm not going to get another value like that. And for factoring, the easiest thing to do factoring is using quadratic formula right here. So I'm going to use quadratic formula to try and solve for my cotangent theta. So I'm going to set it equal to, so first, A is going to be what? 3, very good. B is? Negative 3, and C is? Negative 1. So my formula, negative B plus or minus square root of B squared minus 4AC all over 2A. So we're going to use this information to try and solve for cotangent theta. So this is going to be cotangent theta equals whatever values I get from my quadratic formula. So this is the easiest way to actually do this all the time, because it works all the time. So it's going to be negative 3 plus or minus square root of negative 3 squared minus 4 times 3 times negative 1 all over 2 times 3. So if I do my math right here, just so I don't screw this one up, I'm going to clear my calculator out. Clear the scratch pad, press Doc B. Alright, so right here, I'm going to get, this is going to be positive 3 plus or minus square root of something. Let's figure out what that something is. So, negative 3, close, square, minus 4 times 3 times negative 1 gives me 21. So I'm going to have 21 on the inside here over 6. So this is actually solving for my variable. So this is actually, if this was a variable x, I would have x equals, or if this is a variable y, it'd be y equals. But since this is going to be a cotangent theta, so it's going to be cotangent theta equals 3 plus radical 21 over 6, and I have cotangent theta equals 3 minus radical 21 over 6. Now, we're still trying to get to the point where I solve for theta itself. But I have this set up here where it's factored out, and so I have these right here. So what would I do to try and find my theta right now?
Divide by 2.
Nope.
Oh, multiply by 6.
Nope, you're trying to break it apart. You're trying to get the theta by itself.
You subtract cotangent.
Oh, you do the inverse?
Inverse, that's what I'm looking for. Yep. So, we're going to do the inverse of each one of these. So, I'm going to do the inverse. Make sure your calculator's in the right mode. And so, this is degrees here, matching here. So, it is inverse cotangent of 3 plus radical 21 over 6. Does that make sense?
Yeah.
Okay. Enter. So I'm going to get 38.4. So that's one of my answers.
Oh, well,
That's one of the answers there. So I'm going to do it again, but this time it's going to have what?
minus.
The minus, right? Ah. Now it's the minus 1. 104.8. Now, for this to be correct, I need to have more answers. So for cotangent, for this one right here, for this to be positive right here, right? For this value, it's positive in quadrant 1, and it's also in quadrant 3, right? So how would I move from quadrant 1 to quadrant 3? How much am I moving it to go from one to the other?
Oh, 180.
I'm adding 180, right? So we're going to do that to find my next answer. So I'm going to take this one and add 180. So 38.4 plus 180. 218.4. Now, for this one right here, this one's in quadrant 2, isn't it?
Yeah.
And to get all the way across to the other side where quadrant 4 would be, I need to do what?
Add 90.
Add 180. 180 again. So I'm going to add 180 again. So let's go ahead and do that.
284.8. Yep, 284.
284.8. So there's all the work by hand. That's all the work by hand, okay? So now I'm going to show you shortcut method, which will give you partial points, but everyone's going to do this anyway because it's going to check these answers. So there's no reason why anyone should get any of these wrong because you could check your answers on this. So calculator only. Same thing happens. I set it equal to 0. So it's going to be 3 cotangent squared, but this time I put the x degrees minus 3 cotangent x degrees minus 1 equals 0.
Put it in the graph.
I'm going to put it in the graph. So now, got the calculator. Let's see. Is it on my screen, hopefully?
Yeah.
I'm trying to make sure it's recording right. All right, so 3 cotangent of x. Ah, crap. I didn't say that on live. I did not record that. Okay, don't forget, put the square on the outside over here. Minus 3 cotangent of x degrees, close, minus 1. So now that I have it entered there, what do I have to change from there?
Window.
Yeah, I got to change my window. So menu, window, what is my window got to be?
0 to 360.
There we go, 0 to 360. Now, here is my 4 answers. There's my 4 answers. Now, let's go ahead and check those. Menu 6-1. There's my 38.4, right? Now, do it again. I get, for this next one, it is 105 degrees. Let's check the next one.
Oh, they just rounded it more.
Yeah, they did. 218. And my last one and 285. So I have all these right here, so they're all the same, aren't they? But these ones are just rounded further. Okay, this one is round to the 10th. So it says give solutions to the nearest 10th. In my question right here, give solution to the nearest 10th. Okay, now does that make sense?
Yeah.
So everyone will get these answers correct over here. There shouldn't be anyone that gives any of these wrong. But then by doing it by hand, you could check your answers to show where your work is supposed to be at here. But for full points, I need to see all this work. Half points, only this.
Even the calculator?
Huh?
Even the calculator?
What do you mean? Calculator only is partial points. Is that what you're
You
asking?
need to add the by hand and calculator for points?
Okay, so if you want full points, you're going to do this. So you can get this answer right here like we did, but there's a reason why. Why did I do the calculator part also? Does it check every single answer? Yes, it checks every single answer. So that's what I mean by you have no reason to get any of these answers wrong ever. But it's just depending on your full points. If you're going to get full points or you're going to get half points. Okay? That's what I'm going for.
Is that on the reference sheet, I'm guessing?
Oh, this one?
Yeah.
No.
No?
We're going to add this later. We're going to add this for the test. I'll put it on the board for you guys.
All right. Oh,
All right, so let's take a look at the next one. I'm going to make sure I line my video up right.
we don't have 4 or we don't have 2 for the written?
There's 2. Only 2.
Oh, wow. Oh, awesome.
All right, same rule. Same rules apply. So what is the first thing I have to do?
Set it to 0.
Set it equals 0. Scotty Beard, come on. Secant squared theta, tangent theta minus 2, tangent theta equals 0. So from here, do these have a common factor?
Yeah.
Yes, what's the common factor?
Tangent.
So I'm going to take out a tangent. And I'm left with secant squared theta minus 2 equals 0. Now I have it factored. At this point it is factored, so I could use zero product rule now. So that means zero product, I could set each one of these equal to 0. So tangent theta equals 0 and secant squared theta minus 2 equals 0. Now, for this one right here, I need to find this from the unit circle. Where's tangent going to be equal to 0 on the unit circle? So now think about it. If tangent is sine over cosine, I need the sine value to be 0, not the cosine. So it's going to be where? Why is it not 2 pi?
Oh, because it can't be 2 pi.
It can't be 2 pi, but what it can be is, it could be 0, right? So it could be 0, so 0 could be one of my answers. So it's 0 pi. And what's another place that it's equal to 0? At pi, right? So these are 2 of my answers. These are 2 of my answers right here. Now on this next one right here, I'm going to start by adding 2 to both sides. So it's going to be secant squared theta equals 2. How do I undo a square?
Radical.
Radical, square root, right?
Yeah.
So it's secant theta is equal to plus or minus square root of 2. So I always have to include the plus or minus here for this. So, now for this part right here, we know that secant is the reciprocal of cosine, right? So there's only one place on my unit circle that has a radical 2, doesn't it? That's actually 4 places, but we'll get to that in a second. So in quadrant 1, there's only going to be one place, because if this is reciprocal of cosine, let's take a look at what the cosine would be. So if it's going to be 2 over radical 2, this is my pi over 4. Hold on. Slide it up. Right there. Okay. So it's pi over 4. So this is secant at pi over 4. Can I leave the radical in the denominator?
No.
Rationalize.
2
rad 2 over 2, right?
Yeah.
So that cancels and just gives you rad 2, isn't it? Okay. So for a positive radical 2, one of my answers is going to be pi over 4, isn't it?
Uh-huh.
Where else can I get a positive radical 4 or positive radical 2?
3 pi over 4.
Not 3 pi over 4. Isn't 3 pi over 4 is that cosine a negative?
5 pi over 4. Oh.
5 pi over 4?
7 pi over 4.
Look on the unit circle. Look on the unit circle. Isn't 5 pi over 4 negative also? Cosine's negative there, isn't it? I want a positive.
It's 7 pi over 4.
Thank you. 7 pi over 4, isn't it? So both those places cosine is positive, isn't it?
Yes.
And both places I started off with my rad 2 over 2, right?
Yes.
Okay. So now let's take a look at the next one. So what about the negative? For the negative value. So that means that the cosine had to be a negative also in that same place.
Uh-huh.
So that would give me
5 pi over 4.
5 pi over 4
3 pi over 4.
and 3 pi over 4. You guys see those?
Yes.
Yeah, on my unit circle, that's where I'm getting those. I'm actually taking the radical 2 over 2, right? Radical 2 over 2. Raw. And I flipped it over, right? I flipped it over to get that. And every single place that I had that is actually one of these. Okay, the positive and negatives. So my whole solution set, yes, go ahead.
Isn't secant 1 over, it's 1 over x, right?
Yeah, so it's the reciprocal of cosine. So we're looking at all the cosine values.
How come you did 2 over radical 2?
Okay, the cosine, what's cosine at pi over 4?
Oh. It's, 2 radical 2 over 2.
Yeah, and then I flip it over because that's a secant now, right? Or secant is a reciprocal, so I flip that over to be this, rationalized, came up with that.
Oh,
That's what I'm looking for here.
alright.
So my answers in order is going to be 0 pi, pi over 4, 3 pi over 4, pi, 5 pi over 4, and 7 pi over 4.
Do you have to put it like that?
Yes, in order. Yes, you do have to. Now,
You did put pi.
Oh, you did?
huh?
Oh.
To the middle.
Look,
Yeah.
look, there is 6 answers here. 1, 2, 3, 4, 5, 6.
Oh, okay. I see.
Now, calculator only. Same step. Secant. So I'm going to actually show you, I'm going to put in the calculator like it would be. So it's x degrees outside squared. Tangent, x degrees minus 2. Tangent, x degrees equals 0. So that's the same thing right here, but this is how I have to put it in the calculator. So on my calculator, let's see, can you guys see this? Slightly off, there it is. All right, so I'm gonna change this one. So my window's already set up, so I don't have to reset up my window for this one. So that's secant squared, x degrees close squared, tangent, x degrees close minus 2, tangent, x degrees close, hit enter. Your calculator might lag a little bit on this one because there is a lot going on there. All right, so let's take a look right here. Does it look like 0 is one of my answers?
No. Yes.
Let's take a look here. It looks like 0 is one of the answers, but how do I check it with the calculator?
Hit.
Menu 6-1.
Menu 6-1. How do I check it if my window's from 0 to 360? How do I check the negative number?
Type in -1, enter, right?
Yeah, just a number to the left of that, right?
Yeah.
So like a -1 would be fine, or a -5. I like being a little bit over. So -5, enter, and then go to some point right here. So there it is. It gives me my 0 as one of my answers right there. So it gives me a 0, 0. So therefore I have a 0 degrees. And don't forget, all these answers now are in degrees. So you're going to have to do some conversion from the calculator one. All right, so the next one pops up already there. That's 45 degrees.
Can you just look it up on the unit circle too?
You can do that too, but on your test, it might not be there, so you're going to have to convert it.
Okay.
Okay. Next one, so menu 6-1. I'm going to have 135. Next one is 180. Menu 6-1. 225. And don't forget, if your calculator start lagging, delete some of your spots. And 315 degrees. So to do that, I would just take one of my values, click on the point, and when it's blinking, I hit delete, and it's gone. So it helps if your calculator starts lagging too much. There you go. All right, so 1, 2, 3, 4, 5, 6. I have all 6 answers here. You could pull these from the unit circle, or you could do the conversion by multiplying by pi over 180, right? So this gives me 0 pi radians. This is pi over 4. This is going to be 3 pi over 4. Pi.
5 pi over 4, 7 pi over 4.
All right. Questions? Easy enough, hopefully. Don't forget, like, subscribe.
You still haven't done
Leave comments down there.
no face.
I have no faith.